So here, this is example 2.1. Again, I get this right off the lecture and example page. And it says sketch position versus time graphs. And I'm also going to sketch velocity versus time graphs for the following motions. Include a numerical scale on both axes with units that are reasonable for this motion. Some numerical information is given in the problem, but for other quantities, make reasonable estimates. So typically, I expect you not to use a ruler to draw lines. I'm lecturing. And because I have to communicate that, sometimes I do use a ruler to make lines. Like if you look at my graph right here, I did use a ruler to make the green and the red line. On quizzes and exams, I don't know if you have the luxury to actually do that. So what I'm saying here is that if you show me a rough graph that looks something like this, I'm not going to grade you on how pretty your graph looks. You just have to be able to show it to me. Okay, so let's look at example 2.1. Carmen walks to the bus stop, waits for the bus, and then rides to campus. Assume that all the motions is along a straight line. So let's go look at this guy right. So what I want to do here is that I need to sort of draw a motion diagram, and I want to draw a graph so that it's reasonable. So I'm assuming that if Carmen's walking, her speed should be slow compared to the speed of the bus. So therefore, the slope for Carmen should be small, but the slope of the bus should be higher. Now, in this situation, what I'm doing here is that I'm assuming that there is no change in velocity at this point. I could add change in velocity, but what happens here is that it's a complication I really don't want to go and look at here. Okay, so what we want to do here is that let's assume only constant velocities. In other words, when I look at change in velocity, I do not want to consider that right now. It's easy to add change in velocity with a little bit of practice, but we're not interested in that kind of practice right now. So let's start with the motion diagram, and then let's make that into a graph. So if I look at a motion diagram, here I go. Carmen is walking to the bus stop. So what do I assume? What I assume is that Carmen is moving at a constant velocity. Right? Here's her 0. And so what I'm going to be looking at is that she's going to be moving right here at a slow speed. Okay. Now, here's the thing there. So this here is constant velocity. Okay, so I'm going like, yep, here's the velocity, here's the velocity, here's the velocity. Now, here's the crazy part. Right here, she instantly stops. She instantly stops right there. And what she does here is that right here is that she now waits for the bus, because that's what the question says. Now she hops on the bus. Now, typically, that's not the way I would draw this. So what I'm going to do here is that I'm going to copy this, and I'm just kind of putting information there. So now, here's what I would say here. So right here, I would then say that right here, she then stops and she waits. Stops and waits. But as far as a motion diagram, that dot does not change. Now she gets on the bus. She gets on the bus. The bus does not speed up. It is instantly going fast. So then I'm going to say here that then the bus now is then going to be moving this fast. It's instantly going this fast like that. So this is now a constant velocity, but now moving faster. So again, if I set up my coordinate system, I'm going to say that this is right, and I'll call that positive. So how does my graph look? So now what we want to do here is that we want to plot position versus time and velocity versus time. So let's do that. So if I look at my graph, I'm going to say that it looks like this. So Carmen moves at a low speed. So what does that mean? What that means here is that I'm going to say that her slope has to be really small compared to the bus slopes. So I'm going to come in here and I'm going to say, okay, this is the slope of Carmen right here. So at this point, this is where she now waits. So again, this is Carmen's speed, or not Carmen's speed, excuse me, Carmen's velocity. Why? It has a small speed and it's moving to the right. But if she waits, what really happens here is that she cannot change position at all. Right? Her position cannot change. And then right here, what happens? The bus picks her up. And what does the bus do when it picks her up? Well, it moves at a higher speed. What do I mean by higher speed? A steeper slope. So now when I'm looking at this thing, right here, I'm not being a very good graph labeler. You can see here that in this situation here, that the bus is definitely moving faster. So we're going to say here is that this is the bus's velocity. So what do I know about the bus velocity? It has a higher speed and it's also moving to the right. So if I was to, you're seeing that there are three intervals that we're looking at. Right here, you could see here's that this distance right here, that's delta x, is a small change. If I look at this guy, this is a bigger delta x. And if you look at this change, this is delta x equal to 0. So graphically, it has to look like this. Now, what does the velocity tell us? Well, we've already drawn the velocity. Right here, we know that the speed must be 0. So now if I look at the graph of the velocity, it has to look like this. So typically I just draw the line straight down. so that we can separate the intervals. And because we're moving at constant speed, we see here that Carmen's speed is really small. But then all of a sudden, what does she do? She stops, so her speed here must be 0. And then when she's on the bus, well, she's moving faster. So if I come all the way across here, you could see that that's a higher speed. So that would be my position versus time graph. Now let's go look at another example. This one's a little bit more complicated. And I'm going to skew this because it seems like the wording is really small here. So now what we're looking at here is we're looking at, it says the quarterback drops back 10 yards from the line of scrimmage and then throws a pass 20 yards to a receiver who catches it and sprints 20 yards to the goal. Draw the graph of the football. Okay, again, we have to pay attention to the slopes. Over here, we paid attention to the slopes because we said what? Carmen walks slower than the bus moves. So therefore, the slope has to be lower. So here we go. Let's start with the motion diagram here. Okay. So here we go. So if I think about a motion diagram, what am I seeing? The quarterback, how about if we just give an arbitrary name, quarterback Joe, for example. We're going to say that quarterback Joe drops back 10 yards. So then if I look at my motion diagram, I'm going to define my origin right here. And here's my origin. That's my x equal to 0. Now, when I think about quarterback Joe moving back, since he's not, quarterbacks don't race. So what I'm going to assume here is that the slope of Joe has to be small. So that means his speed should be low. So here I go. So then I'm going to say here is that Joe is moving back, and he's going to move back. They say that he moves back to what? 10 yards. So, but Joe is carrying the ball. So we're really looking at the football. So now what happens? Joe now throws the ball. And it says it throws the ball and then passes 20 yards to a receiver. Okay, so then here we go. So if it passes 20 yards, then that means here, again, I'm focusing on this, that ball has to go past the origin. Now, if I throw the ball, I'm assuming here that the ball is now moving faster than Joe was moving. So then I'm going to go, there's going to be 1, 2, 3, and again, it's going to be tricky to get these distances here. Oh boy, look at that. So here's Joe's speed. Now the ball speed, I would expect to be higher, going right here. Now at this point right here, this is where, what do I say about receiver Patty catches the ball. So instantly that ball stops. That's why I don't have an arrow there. So now what do I expect? Patty now starts running, but we would expect that Patty is not as fast as the ball was thrown, but it should be faster than quarterback Joe going back. So then if I look at this thing, I'm going to say that now Patty is running this fast, and it goes all the way, I guess, and scores a goal 20 yards. So 20 yards should be 1, 2, 3. So by the way, I should be careful here. This should be minus, and this should be plus 10 yards. So that means 1, 2, 3, was that 2, 4, 6 squares is, so I got to go 2, 4, 6 squares. So then this here should then be the goal line, which is, so which has to be, that total distance has to be 20 yards. So then if I keep going here, it looks something like that. So when I'm looking at this thing, my velocity is not as big as the purple, but it's bigger than the blue. So I'm going to say that that's what my motion diagram looks like. What does the graph look like now? So we're going to say the same thing that we did here as we did right here. So here we go. So now let's draw the graph. So this is my position versus time. And what I'm going to do here is that this is plus 10 yards. And I'm going to say that this is minus 10 yards. And here I go. Look at quarterback Joe. He's going to the left. If he's going to the left, it must mean that there's a negative slope. So let's draw that negative slope. And you could see that this is a speed of v, and it's going left, right? This is the ball's speed. Oh, ball's velocity. But remember, in this case, this is that means here is that right here, that because we're plotting the ball, not anything else. And now Joe throws the ball to Patty, and we would expect here that the slope has to be very steep. So now, what does the ball speed look like? Well, the ball speed now is very steep. So now if I continue to look at the ball's velocity, it has a high speed, but now it has changed direction. And now Patty catches the ball and moves at a, steeper slope. And let's see here. So let me be careful. So if that's 10, this guy right here, so this should be 30 yards right here. So this should be my positive 30 yards. So then I'm going to say that right here. So then if I look at my curve here, this should be steeper than Joe's slope. And it looks just like this here. And so again, if I look at the ball speed or velocity, its speed is not as high as the purple, but bigger than the blue, and it's not going to the right. So now if I look at my my velocities, what do I see here? Well, the blue velocity is negative. So I have to show that. So if it's negative, you can see here is that I'm going to come down here and I'm going to continue to draw my lines to show my intervals right in here. Right? Because I want to see my intervals so that so we can clearly show them. So here I go. So my speed is constant. So I have a low speed. And that velocity is in the negative direction. And now, when I look at my purple speed, you could see here is that speed is then going to be very high, and it's positive. And then the ball slows down, and it's now going to move at a positive speed that's higher than the blue. And there's my graph right there.